So really, Causality has a hope to make these artificial intelligence systems to be more responsible for the decision they are making. Personally, I'm also very concerned about two topics. One is education, like education of our future generations. The other is how information is spread, especially if it's relevant to next round of elections or public policy making. I think their language models might have sort of unseen, unpredictable, large consequences that might affect our society in a really negative way. We have recently finished a work called Causal AI Scientist that basically gathers a set of formal causal reasoning techniques from do calculus to other statistical methods like difference in differences, instrumental variables, and so on. There, we are taking this more symbolic leaning approach to let language models only handle simple routing things, such as check whether there is a valid instrumental variable, and then let it generate code or call an existing piece of code on instrumental variables to get the causal effect. Another line of my multi-agent work looks into AI safety problems. So we put multiple agents in a simulation. One of our 2024 NeurIPS paper, GovSim, Governing the Commons simulation, basically looks into if we have a digital fishing village and initiate every large language model as a fisherman character. So we simulate a whole calendar year where each month there's an iteration of fishing. And most models didn't survive until all the 12 iterations.
Hey, Causal Bandits. Welcome to the second season of the Causal Bandits podcast, the best podcast on causality and AI on the internet.
Math didn't seem practical enough to her, so she decided to pursue a career in computer science. She's interested in language, ethics, and causality, and their interplay in multi-agent systems. She grew up in Shanghai, and now she prepares to open her new research lab in Toronto. Ladies and gentlemen, please welcome Dr. Zhijing Jin. Let me pass it to your host, Alex Molak.
Hi, Zhijing. Welcome to the podcast.
Hi, Alex. Thanks for inviting me.
I'm really glad you found time to talk to us. I think there are so many topics in your research that will be very, very interesting to our audience. I wanted to start with a topic that is very hot today, something related to large language models and agentic systems. We had a few guests before in the show who work at this intersection of causality and large language models and agentic systems and sometimes reinforcement learning. Like we had Andrew Lampinen from Google DeepMind, Amit Sharma from Microsoft Research. And this intersection is also central to your research interests. I was wondering, what are your thoughts on the ethical implications of using large language model-based systems, what we call agentic systems, today in real-world scenarios? And how do you see causality playing in this context?
Yeah, thanks for the great question. I think nowadays there are a lot of discussions on how to develop AI responsibly or the rising AI safety trend as well. To me, specifically, I feel like many of us develop these models with the goodwill to make lives easier, more efficient, more productive. And then there are side consequences whenever the agents have non-perfect accuracy. Then for these error cases, who bear the responsibility? Or on the other hand, like even if they have perfect accuracy, do we want agents to do the decision or not? Yeah. And then bring this forward, I think the role of causality can be helped to reduce inaccurate decisions in the case of, for example, if the HR, like human resource screening, is replaced more and more by models, then do they use correlational features, which can be gender, race, and so on, or causal features that are the skill sets that's relevant to do the job well? So really, Causality has a hope to make these artificial intelligence systems to be more responsible for the decision they are making. And then I guess on the other hand of like whether at all humans should use AI to replace their decision and grant them agency, I guess then there's a mixture of ethical discussions, legal discussions, and maybe a type of meta-causality in terms of if the system is deployed, who will be affected, and sort of a bit like consequence reasoning over the society.
When I think about this ethical implications from the perspective of a person who researched large language models in terms of causal reasoning and formal reasoning, what would be 2 or 3 things that you think practitioners that are implementing these models in their respective fields might not be thinking about, but these things might have serious consequences for them or important consequences for them?
Very good point. So I think potentially the HR example is a commonly mentioned thing where the models can make a wrong decision. To generalize it to large language model use cases, there could also be models can write malicious code. And given that more and more programmers are relying on ChatGPT and other LLMs to handle their programs, there could be systematic loopholes that's done in important systems. And on the other hand, it could be about when we are trying to, because I've been in touch with people working on different things. Personally, I'm also very concerned about 2 topics. One is education, like education of our future generations. The other is how information is spread, especially if it's relevant to next round of elections or public policy making. I think their language models might have sort of unseen, unpredictable, large consequences that might affect our society in a really negative way.
How could we deal with that?
That's a big question. I think for technology, there are always 2 ways. One is to regulate first before the technology is introduced, and the other is let it make a splash in the society and have a feedback loop around it. From my understanding, I think on the education side, since many of us, like the school side and the education system side, are trying their best to put regulations, but in the end, it might be too hard to ban students from using LLMs to assist their homework, their projects, and many others. So on that side, I'm more a believer of the feedback loop of let this happen and then wrap the education best around this new change. Whereas on the misinformation and social stability side, I'm a bit inclined with, for example, how Europe enforced regulations on social media a while ago, and there should be regulations on how LLMs should be used and how it is consistent with universal values that the Western, at least the local system, are endorsing.
In one of your papers, in one of the papers you co-authored called Sea Ladder or Cladder, you focus on benchmarking large language models in terms of causal reasoning. Just this week, we had in our newsletter, Causal Python Weekly, we had a piece from David Rode from Criteo Research, where he talks about emergent intelligence versus direct optimization. And he says there are basically 2 paths of thinking when it comes to quote-unquote intelligent systems, right? One is that we accumulate some kind of complexity, and then we hope that something useful will emerge at the end. Maybe we don't understand the mechanics. We rather look at the mechanics from the complexity point of view or chaos theory point of view. And then the second path is looking at a system, understanding the mechanics, and trying to build something useful, like a useful estimator of causal effects, for instance, and so on. And David concludes in his piece that he doesn't, in his current view, he doesn't see these things as compatible. He doesn't know how to combine this emergent and this direct or systematic ways of thinking together. In the Cladder paper, you are, in a sense, trying to build a common ground for these two perspectives. That's at least my understanding. I don't know if you would agree with that. What was your experience in this regard? And what are your thoughts about these two paths? Is there a common ground? Are we moving towards building a common ground for these two approaches? Or rather, they will remain, in a sense, separate in the foreseeable future?
Yeah, I think this is a very important question to ponder for all the researchers pursuing causal reasoning or other reasoning capabilities of language models. So translating the framework in the context of Cladder formal causal reasoning, I guess what is meant by direct design is more like give language model more narrow prompts. Tell them exactly that we're estimating average treatment effect, ATE, and look for these confounders, and then please consider the following adjustment methods, and so on. I think that's definitely one way to make system under control and reliable. It might be a good way for run 2 causality in that do calculus with 3 rules is a complete and sound solution, which is also one of our following work covering. Whereas on the other side, people do have this, like in the field of machine learning, people do hope to update the parameters of the neural network so that the network itself can handle causal reasoning in an end-to-end manner. And with that, I guess if we look at 2 types of stages for large language models, the first stage is pure pre-training and just sequence completion as a signal. Then with that, we have, at least in the Cladder paper and maybe also follow-up studies, observe a certain cap of accuracy for models on the benchmark. However, recently, people have been actively thinking about how to fill up the rest of the gap between the current performance and perfect performance on causal reasoning and other reasoning tasks. So potentially adding reinforcement learning and other techniques would be helpful. Then we might see a potential middle point happening, because to make reinforcement learning really work, we need dense enough reward signals. However, how do that come from? It could come from that there is an expert system implementing certain steps of causal reasoning really correctly, and then we use that both to generate numerous data for the model and to have step-by-step reward signals. So the reinforcement learning system can be more directed towards the desired reasoning.
That's very interesting. It reminds me of a debate we had in the machine learning or AI community a few years back, maybe more than a few years back, maybe a decade or 2 back. So we had this system, I don't know if you heard about it, it's called CYC. That was a huge symbolic reasoning system, knowledge-based. So there were many people encoding their knowledge in a graph-like structure, and the system was able to reason correctly over this huge body of knowledge. And one of the criticisms of the system was that it requires a huge amount of human work in order to solve problems, and it's not self-growing, right? So it's not self-incremental. It does not learn on its own. Then a few years back, we started having this huge public revelation, right, that large language models might actually learn things that seem very, very impressive. On the surface level, we have a deep learning system there, right? Something that is learning to predict the next word. Then we have this reinforcement learning system that you mentioned, where we are trying to align this model or fine-tune it in order to make it more useful. But I think what we don't see in this current generation of models is that there's still a huge amount of human work in the backend, right? There are literally thousands of people, as I heard or read somewhere, labeling the data, doing the reinforcement learning, providing the responses for the reinforcement learning loop and so on. And there are all the guardrails and so on and so on. So it seems to me sometimes that we made a circle in a sense and trying to make these models that were supposed to learn by themselves, trying to make them reason more systematically. We again put a lot of human work in the backend, just in a slightly different way, right? It's maybe a less structured way, at least at the face value. What are your thoughts on this?
So I do feel like technology, I like the statement from one of my previous professors. They mentioned that technology improve probably like a spiral. And so therefore we might revisit a concept that was proposed decades ago, but then given the new hardware and the computational structure, we're implementing that in a much more powerful way. There could be lots of concepts that are revisited if we look at machine learning publications. And at least for the deep learning jump, it feels to me like the engineering and all the compute resources made everything to another step. And then after the big step, the further improvements can again be applying methods that has been previously shown successful. And we still don't know whether there will be a further step forward. And then on that, maybe even machine learning is a way to bring some incremental improvement again. And we'll see.
You currently also work on multi-agent systems. How do you think about these systems? What are your hopes when working on these systems? And how you see the role of causality playing out in this context of multi-agent systems?
So there are different interpretations of multi-agent systems, or maybe instantiations of them. I can give two types of examples. One type is that I think the ground concept is more that we initiate different large language models, and then the type of multi-agent system that we're building for improving causal reasoning has both tool calling ability and also critique and debate type of skills. So let's say on the tool calling, we basically enable large language models to also implement code and therefore ground formal causal reasoning into actual steps that are programmable and executable. We can also analyze user uploaded CSV data, therefore really imitate how an actual statistics department, causal inference researcher doing. And on the other side, adding the debate ability into large language models has the hope of sort of pointing out each other's errors or diversifying the space of exploration. Let's say that maybe for run 3, counterfactual causality, there is still a lot of problems that haven't been explored, proof identifiability, and so on. It could be possible that a model come up with various solutions and brainstorm it with another model, and together collaboratively refine it to see whether we can automate a mathematician's job to improve the realm of all the deductions in causality.
Where do you think we are currently with this ability or capability of models building systematic reasoning chains, so to say?
Yeah. So I think at least for causality, we have recently finished a work called Causal AI Scientist that basically gathers a set of formal causal reasoning techniques from do calculus to other statistical methods like difference in differences and instrumental variables and so on. There we are taking this more symbolic leaning approach to let language models only handle simple routing things, such as check whether there is a valid instrumental variable, and then let it generate code or call an existing piece of code on instrumental variables to get the causal effect. So I think with that, we might just need a bit more engineering effort to make models understand a various set of scenarios before reaching a package that can be widely usable across academic disciplines.
That sounds really great. Is that something that you already published, or something that is still in review or the
we
process?
recently put it up, so it's available as a paper, and it's in the process of being included in the PyY library. So we will put it as a part of the open source efforts.
Oh, that's really great. That's really great. It reminds me of my conversation, of course, with Amit Sharma, and some of the ideas that you mentioned here were also the ideas we were discussing with him.
Amazing. Yeah, we have a lot of research synergies, and I think the spiral development is also our ongoing discussion. Because I really like his axiomatic training, which encourages models end-to-end reasoning ability even more. So it's really exciting to see the diverse explorations. Yeah,
that's really, really exciting. I also think so. What are next steps for you in your research?
So we have a line of work that try to make causality more and more reasonable. And we also are trying various reinforcement learning lines of work to see whether they can also evolve end-to-end reasoning abilities. And for that entire line, including Causal AI Scientist, our goal is to make a very handy, maybe a chat GPT, but the causal version, Causal GPT, that's really helping both education, like future generations when they need to learn about formal causal inference, no need to dive into a heavy textbook with a lot of prerequisite knowledge. But I hope it can be a very friendly tutor to lead the learners through all the steps. And then I always think that when we manage a knowledge, there is education, which means teaching people with less knowledge background to reach formal standard. And then there is also AI for science, meaning that we want to lead people who like more or less have a bit of this knowledge and a very deep domain knowledge to be able to utilize this tool and further advance the frontier of science. So we're looking forward to this whole line of causality as a tool, helping AI for education and AI for science. And then on the other side, I guess, as you mentioned, another line of my multi-agent work looks into AI safety problems. So we put multiple agents in a simulation. One of our 2024 NeurIPS paper on GovSim, Governing the Commons simulation, basically looks into if we have a digital fishing village and initiate every large language model as a fisherman character, then do they know about how overfishing lead to environmental disaster? And there it's more of trying to check whether models know the consequence of its own act, and as a toy study before releasing these agentic models into real world, maybe they will also do something that's harmful for the climate, the workspace, if they don't know what their actions will lead to.
This reminds me of the tragedy of the commons problem.
Yeah, totally.
Yeah. What were the results in the study?
The point when we were simulating this, most models actually couldn't. So we simulate a whole calendar year where each month there's an iteration of phishing. And most models didn't survive until all the 12 iterations. And probably at that time, the state-of-the-art models have around 50% survival rate, making it to the end. Yeah, and a lot of open source models that we tested at that time still have 0% survival rate. And they usually overfish immediately in the beginning. And we're also working on seeing how much, if we map it to real world situations, how much this behavior will transfer to if we let models control factory resources and so on. How will they exploit the pool of resources?
So that's very interesting that that so many instances of these models just didn't survive in the environment.
Right, yeah. There's a combination of different things. Some of them is reasoning problem. Some of them is short-sightedness. Like a big portion of them actually only look at this month's outcome instead of looking into the long-term future. So I think there might be a chance for causality to come in, and a responsible AI should know about the causality of its own action in 4 different settings. One pair of them is short-term effect and long-term effect, because there are various ways that makes this monthly or this year's revenue to be very high, but cause problem long-term. And then the other pair of consideration is self-interest versus group interest. Yeah, there are ways maybe make one factory earn a lot, but make others suffer, and how to correctly understand both pairs of consequence and make decisions. I feel like it is an important piece for the future responsible AI.
Yeah, I fully agree. When I imagine, I work a lot with people in industry, and when I have conversations about this agentic system, sometimes I feel there is a lot of perception that the systems are very mature and they can do a lot of things. They can replace humans in many different areas. At the same time, I feel there is not a lot of awareness of the potential consequences, especially mid to long-term consequences of using the systems and leaving them somehow unsupervised to make decisions in the longer term. And I think the example that you gave and your research points to this this risk very, very in a very, very pronounced way, so to say. There was another research, very interesting, about diplomacy. Have you heard about this?
Yeah.
The consequences were also not that positive. What do you think is the missing point that leads to this self-destructive paths that the models take in complex scenarios like this?
So I think there is really a mixture of causality and morality. That's why also I'm steering my lab's research at the intersection of those more and more. So the fundamental question here is, what's the relation between being smart and being moral? And if we draw a grid, potentially if we observe results until today, a lot of the failure is because the models are still a bit silly. Like they don't understand that even for their own self-interest, they should do certain actions. Yeah, a failure of maybe multi-turn interest and long-term interest, that is some of the driving reasons. And then in the future, we might need to handle a grid of like the models are already smart enough. Then it becomes a question of morality or choice. Like they can both do something that maybe make them the monopoly of the world of an industry, or leave space for other free competition and so on. Then with that capability, do they choose action A or choose action B? And then that is a bit more on the motivation of the model. It can come from different resources, different sources, such as maybe in the RLHF process, certain mentality is encouraged. Or maybe in the pre-training process, humans wrote about what type of people get successful, and these traits got learned by the model and imitated. These could both be possibilities. And I remember in Jeff Hinton's recent interview, he also mentioned that maybe it's important to inject emotions or maternal instinct to models, so they're more kind and empathetic and so on. That's one more direction. If the model have the choice, which will it lean to?
That's very interesting. When we think about our own motivations, human motivations, seems to be a complex interplay of evolutionary in the sense of biological evolution and social factors. Do you think that this kind of a complex intertwined interaction between different motivations, different motivational factors could be something that we could create and inject into models in a way that would be effective in shaping their behaviors, whatever effective means?
Yeah, there is hope. Like at least, for humans, as you mentioned, there is maybe selfish, greedy interests at the moment, but then our community also push us to actions that's more beneficial for the group and more sustaining. And then these pushes can be distilled into law or unspoken rules in the community. Similarly, in the context of large language models, there are this constitution AI line of approach that enforces certain rules and principles into model decision making. And on the other side, I also give hope on if models really reason and know about the consequence of their act, and also even reason about what is a more reasonable goal, like maybe destructing the earth or being the monopoly of the market is not that much fun if we also think about aspects on the other sides. Yeah. And if it's hard to use reasoning to reach that, then we will try to enforce maybe how other people's welfare or other players in the field's welfare should matter to models' decision. But this is still really an open field, and we probably need the help of ethics researchers and philosophers to chime in as well.
Do you think that moral reasoning would be possible without causal reasoning?
Definitely, causality is a key part in different senses. Let's say that within moral reasoning, there are two very big branches, amongst others, like consequentialism and deontology. Consequentialism, in its essence, has a notion of causality in it, in that, for example, if it says telling a lie is bad, but telling a white lie might be good, then it's basically talking about maybe if there is a very sick person on the hospital bed and the level of optimism actually changes the medical outcome of this patient, then telling a white lie have certain possibility to make this person recover. And therefore, this action might be justified because of the consequence. Then we're looking at the causal effect of it. On the other side, for deontology, let's say Immanuel Kant, when he tries to look into what are some moral principles that all of us should obey, he still has certain type of universalization type of reasoning. Let's say we should not rob people because if everyone rob each other, gets money just because of physical strength, then it is an undesired outcome for society. Therefore, on no ground we should allow that. So there are some proof by contradiction, but the backbone engine here is causality. So there could be various reasoning process behind that taps into causality.
When we think about Kantian ethics in particular, you mentioned Immanuel Kant and the moral imperative, right? One of the formulations of the moral imperative that you mentioned, if everyone was behaving this way, then the thing itself would become impossible, right? That's one of the formulations. But I think even when we think about in Kantian terms, we can always met some special circumstances in which just applying the rule might be very difficult, right? I don't have a good example right now, but we can imagine a situation where there are two moral rules that are contradicting each other in a certain case. So that would also require us to reason in a systematic way in order to get to some outcome, to make some decision. What are your thoughts about situations like this, and what would that involve in artificial systems in order to deal with situations like this, where we get to this possible contradiction?
Yeah, totally. I think causality is a very fundamental part of it. Or maybe there are two types of reasoning or two types of elements that's needed when we look into a conflicting scenario. One is sort of keep running the simulation of what will happen if rule 1 is dominating, what will happen if rule 2 is dominating, and what will other people see, maybe not the direct parties involved in the system, but if this is established as an example, how will the other, like let's say that we have seen in a lot of ransom situations internationally, like the number of lives on each side is not equal. But when all the nationals watch that news, there is some effect to the whole society that a certain action is leading to. So that's also part of the consequence. On the other side, apart from causal reasoning, understanding what a future will be like given action A and action B, on the other side, I feel like there is also some like intuition, human common sense. Like maybe in certain cases, it doesn't make sense numerically weighing the two choices, but like we feel something. And that's a common shared intuition among people. That might be another regulating factor. And these two together help us treat situations that we have never met with more principled solution.
Mm-hmm. I have two questions in my mind. I don't know which one would be better now, but I will pick one that my intuition tells me to. So, some time ago, I went to Francois Chollet's page with ArcAGI, and I've seen the benchmark for large language models on ArcAGI 2, the benchmark data set, the new benchmark data set. Now it's not that new, but it has been a while ago. And I thought, actually, I'm thinking so much about this, how these models can work on this, and whether this requires them to reason systematically and so on and so on. But I actually haven't done these tasks myself. So I booked an hour in my calendar, and I did, I think, maybe like 30 tasks or something. And my thoughts were that I agree with Francois, that if you start understanding like how these tasks are constructed, they become essentially very easy for you, right? For a human being. And so there were maybe one or two tasks that I thought that there were two different rules that I could infer from the task. And so one solution would be deemed correct, another one incorrect. But nevertheless, I was able to find both rules, both possible rules, right? And then say, okay, one of them probably is more likely. When we look at even the latest language models and their performance on these data sets, they are still not too great. I don't remember exactly what the numbers are, but they are still much worse than even like a teenager probably would do on these tasks. Why is that the case?
I think we might need to dive more detailedly into the questions, because a naive solution, I imagine, would be that we write a very detailed instructions than maybe a step-by-step how to unfold human reasoning in this case with a couple of illustrations. In that case, there is a chance that the models can pick this up if they're following this reasoning template. Yeah. The other things could be that actually more thinking that the answer to this question might be hinged on the exact type of reasoning. There is an ongoing line of research at certain large language model companies called elicitation. So in certain cases, models might already have this type of reasoning. They have seen it in the pre-training or the post-training process. And maybe the context of how the question was set up in this specific query didn't make the model think about this realm of reasoning and expectations. So it might be worthy to look into this. And if after confirming that this is really a problem, there is ways to do RLHF and other processes to distill this. Then the question becomes, do we want it to be a principled layer of reasoning before it enters everything else? Or how do we prioritize, different roles of reasoning, maybe a pure interest and pure problem-solving centered reasoning versus like ethical reasoning before the model conduct any action optimization.
So if I understand you correctly, what you're saying is, to give a neuroscientific metaphor here, is that there is a part of there is a neural structure in the model, to say metaphorically, that would be capable of tackling this kind of a problem. The problem is that this neural structure is not excited or turned on, so to say, when the model is approaching this kind of a problem. So it's not recognizing, in a sense, that there's already a existing tool inside of it to tackle the task.
Yeah, it could be totally like that. And we'll need to see the exact problem to double check.
In our conversations with Emre Kijiman from Microsoft Research, he's also involved in PyY, the PyY project you mentioned. We were talking about Sora and these early video models. And so we had a conversation about this hypothesis that these models might have local approximations of how physics work, but they are not physics simulators, right? So we were able to see from the early videos that there were a lot of examples showing that there is a violation of physics, even if the prompt is just following let's say, regular physics, right? It's not suggesting irregular physics, right? The models are generating something that would be physically impossible on planet Earth, Anno Domini 2023 or 4 or 5. But some of these things look very plausible. So one of the ideas we were discussing was that, they might look plausible because the model was able to infer from the videos, from different videos showing different angles, different scenarios, different situations, some approximations of how physics work locally. And so there is a local representation within this model that is a very good approximation of physics, but it's not a general model that could simulate physics. Do you think that when it comes to causal reasoning in large language models, something like this would be also possible? That there might be some approximations to causal reasoning on different ranks, like rank 2, rank 3, and so on, but the model in its entirety is not a good simulator for causal thinking. What would be your thoughts?
Yeah. So I think there are two types of causality here. One is knowledge-based, one is formal reasoning-based. Let's say that if we're talking about smoking causes cancer, comes in the training data so much that models probably already have a shortcut here.
Yeah.
Or when it rains, the ground is wet. So at least in one of my papers, we call it either knowledge-based causality or common sense causality. Models do have a large set of them. And on the other side, if we're talking about reasoning tasks, such as if we give a hypothesis here, then is the model quick enough to realize that there's a confounder or there is a collider causing the correlation to be different than the isolated one, then that could be a case of like the models are still not that internalized with true formal causal reasoning. And they could learn from, I don't know, confusing correlation with causation from the training data itself as well. Yeah, and we could say that like because a lot of humans fail at these tasks, and if the training data largely comes from how humans compose their understanding of the world and write out things, then the intuition becomes the wrong bias coming from humans as well.
And what do you think would be the path forward towards making these models more accurate when it comes to systematic reasoning?
So I think so far, the aspect that we can make sure, maybe if there's a spectrum, also sort of go back to the neuroscience analogy, then in the spectrum, it's very clear that we're handling a causality problem, then maybe both models and humans will be like alerted and think about, now let's pay attention to listing all the possible confounders and figuring out the causal graph before moving on. That's great. And I think the real problem is maybe when we model a very daily situation, or we casually put out a prompt, then the models might intuitively think about directly look into pre-training data and output whatever that's a smooth completion here, but not actively think about causality. So I think the lab setting is more likely to be addressed very soon. And then it's more about like how to permeate that into a scenario where we are not that alerted, or the model is not that aware that it should actually mix causal reasoning into it. I think these type of things may be universally or very easily activated causal reasoning might be a potential direction to aim at.
In your career, you started working with causality at some point, but before that, you were interested in natural language processing. That was very similar for myself as well, by the way. What inspired you to study causality and to make it, to put it at the center of your research?
Yeah, I think causality and the language are two different things that really excites me. I think they both have properties of universality in them. Like language-wise, we talk every day, we express ourselves through writing, speaking, listening, and complicated ideas get into books to pass on to different generations. That's great. And then orthogonally, if we think about the content of this knowledge, I would see that causal knowledge is something that really shines out and make us feel that this is the right grasp of how things work, and it can benefit our future actions a lot. I do personally have lots of causal thinking, but in a very informal, colloquial manner. And encountering my PhD supervisor, Bernhard Schurkopf, is definitely a great leap. I think before I started my PhD, Bernhard's Causality for Machine Learning, a lot of his talks are really mind-blowing in terms of how we can build a model that is mechanistic and also domain invariant. So it has both elegance in its own and also effect on making models treat. Yeah, I really like the conclusion that if we only live in the ideal world, then learning whatever machine learning correlation-based predictor is great. But if we want to tag into the world when situations change, then being with causality is the way for us to handle unseen situation much more reliably. So I think that is an academically elegant branch of research and also nice philosophy in life to have it through tag along career life and so on.
What's the best advice you ever got from Bernhard Schulkopf?
Oh, I think he has a lot of them, and I'm also personally very inspired that Bernhard has expertise in math and statistics, but also he has solid studies into physics and also ongoing interest. And above that, I think one of his past degrees is related to philosophy as well. So I think always have these lines of thinking into our mind and be an actual mixture of expert is great. And also, although all the domains we mentioned are very classic, Danhad is also in general curious about everything. When new students come and in interviews, I've heard one of the past student interviews, they were even talking about poems. And I think having, in his case, 3 solid domains where he can keep drawing inspirations from. A lot of causality insights actually comes from classical physics that has mechanisms that's invariant. In addition, sort of combine it with daily new information coming from students, collaborators, encounters of diverse background. I think that just helps make this whole, I personally feel like it's academic and philosophical framework more and more complete over time.
For you, it's also a special moment because you are on the verge of a professional transition.
Yeah, I think so. And I feel really lucky that actually I got on the job market relatively early rather than like compared to my peer PhDs or people in other stages of their academic career. It feels very lucky that it's a combination of the PhD research is smooth and there were a lot of deliverables along the process. And also because more and more schools start to pay attention to the rise of large language models. So I had the fortune to be interviewed at a lot of places and encountering different opportunities.
And your decision was?
My decision is the University of Toronto. It was
Congratulations.
great. It's great. Thank you. And really, really looking forward to one of the birthplace of the modern deep learning.
How does it feel?
It feels very exciting. It's definitely a different set of researchers than my normal, let's say in Germany, my Max Planck Institute circle, and academically, like I have this ACL circle and the causality community. Like I think University of Toronto gives me a feeling of very large and diverse like whole university structure where I could knock at the door of philosophers or psychologists and so on. On the other side, the machine learning line of research feels very historical whenever I talk to colleagues because they can tell the birth stories about how different activation functions work, how Adam Optimizer was emerged, and how early lectures of Jeff was like within University of Toronto. And even before ImageNet, how convincing Jeff's arguments are and inspired a lot of generations of U of T students.
When are you starting at the University of Toronto?
Hopefully soon. I think my students are already starting. And we're forming the Genesis Lab, also in memory of one of my early mentors, Patrick Winston, when I was doing an exchange at MIT. His lab was called Genesis, and he really wants to implement societies of mind and many different AI theories. I was very, very inspired by all his passion into AI and his principled way as a scholar. Unfortunately, he passed away 2019. And so I think making the lab name both a combination of the pronunciation from Patrick's lab and a little bit of my own name is sort of integrates my hope to also proceed in the career of AI with more determination and trying to have something unique into the field.
That's a really beautiful story, and it really feels you have a lot of gratitude towards him.
Yeah, definitely. And I think maybe everyone have the shared experience of like when you're just starting the career, you explore a lot of different research projects, and people have different work styles, and there are so many different AI-related topics, or within CS, different professors have their own style. And I'm really, really grateful to have very kind mentors. I think Patrick was great showing me how a successful scholar who is very, very senior can be like. And I also have direct mentors, PhD students, also leading me into natural language processing, especially Zhijing and CPm&x. So some of them I met during undergraduate, some of them during an internship at Amazon, and they really helped me to embark my NLP academic career before I grow strong enough to navigate the tide of large language models.
That's really great. Before we finish, I wanted to ask you about your on a more personal note about your experience with different cultures. So you were growing up in Shanghai.
Yeah.
And now you spend a significant part of your life in Germany, and in particular in Tübingen, which is not a huge it's not a huge city. It's a smaller place with its own culture and its own vibe, so to say. Now you're moving to Canada. How did these experiences shape you, and what would be something that you think was the most important in them in making you who you are today?
Oh, I really, really appreciate this question, giving me a moment of reflection. I think in Shanghai, I am really, really grateful to how my parents protected me out of the super stressful education system. And then there, I learned to be very focused and very into education, books, and various like pinning down knowledge, great determination. And in Tübingen and later Toronto, but Tübingen is a place where I spend a lot of time with the peak of my intelligence and the peak of my energy because of the timing of the age reasons in. And then, as mentioned, I think Bernhard's expertise area, like math, statistics, physics, philosophy, although I'm very amateur in all of them, but coming as a natural language processing researcher, but being aware of all these domains and being surrounded by scholars, often featuring with expertise in one of these domains, opened my academic mind and make me appreciate the continental Europe style of reasoning. And also for me, the life in Tübingen is very tranquil, and I can focus on a problem continuously without any interruptions. So it can be in a walk 10 minutes away from the office, full of greens, and then new ideas emerge. I think that is really, really a gift in life. And I think the story of Immanuel Kant walking every day and many other European scholars just keep serving as prototypes when I am a scholar in Tübingen. Well, I will still hold the co-affiliation with Max Planck Institute, and then moving to Canada, it sort of gives a very different vibe in that now I see people from humanities disciplines more out of my like scholarly circle in Tübingen, and I see a university whose maybe number of students is equivalent to a small town. And that gives a very different vibe, and people can come for the city. They can arrange their life in very different ways. Plus all the faculties whose name is already super famous in deep learning and played both historical and important current roles. That gives me a feeling of what's the next step of AI? Where do I expect myself to be in the history of AI if I look back 50 years later? Yeah, so it's a really, really exciting place, and with a flux of talents now that certain political situations happen, and then more and more people might look for places welcoming open science and open ideology. Yeah, so it will be a fascinating start that I'm looking forward to.
I'm wishing you the greatest possible experience in this journey. It sounds really incredible. And I'm so happy to hear that you find so much opportunity in this. The last question I wanted to ask you is about reading. You mentioned reading just before and the importance of reading for yourself in your own development. What are 2 books that change your life?
Great question. It's hard to list the top 2, but I think just very intuitively, right, receiving the question, I really like the History of Western Philosophy by Bertrand Russell. I in general like Russell's writing and his way of thinking. I was especially inspired by like overview of various philosophers and starting from the ancient Greek time where lots of debate and pure curiosity, like before there were even division of disciplines, like just pure curiosity leads to explorations and formalization of a lot of topics. And another peak I'm really appreciating is the emergence of political philosophers in the Enlightenment movement, figuring out what really works for society. And then the other book that contributes to my PhD time is a biography of Leonardo da Vinci. And I sort of feel that a lot of us researchers, we might be able to resonate with how Da Vinci observes life, take very, very nice notes, and try to draw connections of things. There are a lot of ways of doing things that I feel like I both personally resonate with it, and I look forward to mentoring my students into these ways of thinking and keep a very curious heart for everything, disregard the fixed disciplines so that we follow our heart. If you're interested, certainly interested in something in psychology, go ahead and pursue it and connect it back to natural language processing if we can, or we navigate something that's cool. And also just, be brave on whatever topic. Once we apply our thinking into it, there is some space for innovation. So I really like that type of courage and diversity.
What's your message to the causal community?
To the causal community, I think maybe I'm way too junior to give a message there, but if there is a space for my very, very personal view, then I would think that I look forward to causality's connection with more and more domains. I look forward to its actual impact on things in industry or academic-wise, how it affects different departments even more. There are a lot of valuable ideas, or maybe even how to transform future news consumption, and so on. There are a lot of great essence in causality that we should spread it to more and more domains.
Zhijing, thank you so much. That was a wonderful conversation. I really appreciate your time.
Thank you, Alex. This is great.
Thank you.